Welcome everyone to this Atlas live session. I'll do a bit of an intro to Simon's talk while we're waiting for all the participants to join, so they don't miss any of his stellar content. Yeah, thanks for coming along. Obviously, soil science and cost of soil carbon measurement is a critical topic for running a successful carbon project. Soil sampling is one of the biggest costs for a project, but it's also one of the biggest benefits. By actually measuring changes in soil carbon means that the credits have high integrity and higher value in the market. So whilst it's an upfront cost, it also has benefits when you're looking to sell your credits at the other end of the project. But bringing down the cost of soil sampling and testing is essential. It's going to make more projects viable and also potentially allow for more regular testing, so there's more timely carbon credits. To this end, the Australian government has the National Soil Carbon Innovation Challenge, which is aiming to bring down the cost of soil sampling from between $20 and $30 per hectare to $3 per hectare. So that'll be a massive difference. As part of this, they've provided a number of grants to Fast Track Research, and Hone are one of the recipients of a grant that has recently been provided by the Australian government. Atlas is partnering with Hone, where we're using them to do the soil testing for all our carbon projects, but we're also partnering to help them deliver the National Challenge grant. And that includes being able to provide financial support for soil testing to landholders who sign up. Dr. Simon Wheeler is Head of Operations at Hone. He's going to walk us through what Hone does and what work they're doing to make soil carbon testing more affordable. Simon brings his research and academic background covering nutrient exchange between plants and soils to the challenge of helping farmers improve their soil and build the value of their business. If you've got any questions as we're going through the presentation, put them in the chat. The Q&A has been disabled just so we've got one place to look for your questions. So ask away and take it away, Simon.
Thanks, Sean. Much appreciated. And I think thanks all for joining us today. Hopefully you're having a bite of lunch as you're digesting a little bit of information about soil carbon measurement. Just pop my screen up here. Get this slideshow running. There we go. So yeah, here today to talk about some emerging low-cost and portable solutions for the measurement of soil organic carbon. Thanks for the introduction, Sean. I'm Simon. So what am I doing here? Look, more broadly, I've always been very curious about the world, and that caused me to pursue a career in science. Then got out of, I think, the university funnel and thought, okay, where's some really cool technology that we can use to bring that science to life? And that was how I came to Hone about 5.5 years ago. And then I think sequentially, really developed a passion for first the tech. And then in those early days, I spent months and months sleeping in a farmhouse out at Karuna as we started to collect our first data on the prototype Home Lab Reds, which were soldered to Raspberry Pis at that time in an old engineering attic. They gained a real passion, I think, for taking tech and giving it to farmers and providing it in a way that delivers value, and a real appreciation for what landholders bring to not only the ecosystem, but I think the nation as a whole. And then from there, with the rise of, I think, interest and funding around soil health and soil carbon particularly, saw a real opportunity here to not only utilize the cool tech, deliver something that brings value and information to landholders, but then also has a potential positive impact for the planet. So those three things all kind of aligned, and how we've ended up here today with Atlas and with Hone. So a little bit more about Hone is we're really about making laboratory-grade chemical analysis accessible and instantly available to anyone. So we have this vision that you can test on your farm what you want and when you want. And naturally, then we have a staged release of our instruments, our handheld instruments, which will pop up on the next screen, with the goal of taking that measurement in field and making it cheap. So here it is. It's the HomeLab Red. I'll speak a little bit to what actually is this magical torch and how does it work. The state of carbon projects in Australia, and I think some really exciting developments in the last few months where we've seen the realisation of ACCUs, or Australian Carbon Credit Units, on the basis of storing carbon in soil. Speak to how measurement acts as a barrier to uptake there, and then how we use the HomeLab Red to reduce that measurement costs. And finally, I think for anyone in the room who's considering a soil carbon project, and I'm really eager to receive the questions that pop up after the fact, how to get involved and what does that mean for you individually. So with respect to the current state of play on carbon projects, we've seen this really big uptake year on year of soil carbon projects across Australia. Now, they're typically concentrated at higher rainfall zones and exclude a large number of rangelands and cropping country, but that's really due, I think, to the cost of measurement that sits across these projects. And really excitingly, as I mentioned, we're starting to see ACCUs realised out of those projects. So I guess some basic terminology that sits over the top of everything that we'll be talking about today. When you register a soil carbon project and you sign on the dotted line with a project manager such as Atlas Carbon, an independent team will go out and sample your soil to conduct measurement to determine what are your baseline carbon stocks. So what's the state of play when we start? We then go back within 1 to 5 years after that initial sampling round, and sampling is conducted again on your property. That sampling plan is determined entirely randomly, so the process itself is very strictly regulated, prescribed by the Emissions Reductions Fund and the Clean Energy Regulator. We use that point data to then estimate again carbon stocks across your landmass, and for any increase through time, subject to an audit, the Australian government will issue Australian carbon credit units there. I think a key part of this narrative is the government, really wrapped all around it, and we've ended up in this position in Australia where we're global leaders when it comes to soil carbon due to really quadripartisan support across the political spectrum for the importance of soils and the importance of, I think probably the potential of agriculture, as it has done for a very long time, to drive positive change globally with respect to extreme weather events that we're seeing more regularly. So in just the last couple of months, we've had about 250,000 ACCUs realised across 5 projects through a few project managers. And what this represents is a potential revenue gain of across these properties just a bit over $7.5 million based on the spot price as of this morning. But importantly, what we also see that playing is as we move to understand our entire whole of farm emissions and how they fit into our license to trade, not only in Australia but internationally, particularly with the EU, understanding where your carbon is at is a key part of understanding where your emissions sit more broadly. So I've spoken a little bit about the measurement as a barrier to uptake, but this comes functionally out of the first low emissions technology statement in 2020 from the federal government, and it still stands true today, in that agricultural soils are one of the lowest cost and highest volume drawdown opportunities currently available to humanity. Other methods of carbon capture, for example, direct capture out of the environment, are orders of magnitude higher than the costs associated with drawing carbon back down into soil. And certainly, really since the advent of synthetic fertilizers, we've seen a huge reduction in total carbon within the soil, which tells us that there's also potential to pull that back. The cost of accurately measuring changes in soil carbon is a barrier to the widespread adoption. And the Australian government, the previous Liberal government, and now continue with the current Labor government, has set this goal to reduce the cost of carbon measurement to less than $3 per hectare per year. With current methods of dry combustion and lab analysis, we're currently seeing about $120. So there's a huge room to move there. So I think all this then naturally raises the question of, well, how do you actually bloody measure soil carbon? How does that work? So there's two key methods that are really used under the Emissions Reductions Fund and what I consider the gold standard to measure soil carbon. We have dry combustion analysis, and then we have this spectroscopic modeling, which is where Home really specializes and plays in. You'll note here, I think that I've omitted purely satellite-based measurements technologies, and I think from our perspective, the first uses of that method were first approved in 2021, and we haven't seen really the proof in the pudding that they can deliver, with the dramatically reduced costs, the accuracy that's required to be certain that we're measuring carbon accurately. So I've deliberately omitted that today. So dry combustion analysis is something you might be familiar with. You're sending off soil samples regularly to a lab. You've got the Walkley-Black method, which is commonly used for measuring carbon in an agronomic context. That's calorimetric, and you put in a solution and measure the concentration of light there to effectively determine carbon concentration. That's a method that's not permitted under the ERF method. So we use dry combustion analysis. What that looks like is you take your sample, it gets air dried, ground up, gravel gets removed, and then that less than 2 millimeter air dried soil fraction is then heated at a very high temperature in the vacuum chamber. What that causes is the carbon to volatilize, leave the sample. The sample is then weighed when it comes out of that combustion analyzer. The loss of mass is then used to determine the carbon content there. Spectroscopic modeling is a little bit different in that it uses visible and infrared measurements of soil to determine carbon content. So for anyone who's working in, say, a cropping environment or even in pasture and feed, you may be familiar with the FOSS instruments, which are typically used to measure quality. The technology is exactly the same, just this time applied to soil. So the way we do that is we take our instrument, we collect a whole series of primary data, also is a little bit more, but some soil samples are sent to a lab to undergo that dry combustion analysis, and those are used to then train the instrument to determine carbon content through the rest of the samples. And this is useful not only for formal crediting rounds or baseline rounds, but we're also seeking to leverage this, I think, for the capacity to measure carbon in field and on demand. So it's fast, cost-effective, and environmentally friendly. And what it fundamentally comes down to, I don't have an instrument in my hands, which I usually would, but it's much cheaper to light up the 7 tungsten lamps that sit in this instrument than it is to heat a sample to 1,000 degrees. Is the fundamental way that we drive cost savings there. So I won't spend too much time on this slide, but I know that the meeting's being recorded, and please be coming back to this deck. Feel free to spend some time here. What it speaks to is that process that I just spoken to, but then really, where the Home Lab Red comes in to collect spectral data and then to deploy that data into a field setting. This is what it looks like from a cost basis. So we have a model based on volume, but effectively, if you're executing a carbon project and you're using the combustion only approach, then you will have to take your samples and send them all to a lab. You'll have the 0 to 30 centimeters section. You have to sample at least to a depth of 30 centimeters, and then that 30 centimeter to 1 meter fraction. They all go through the combustion analysis. You get your carbon results. Using spectroscopy, we can reduce that by sending a fraction of those samples in the first round. So it's at least 60 samples. So we have 2 samples per core. And then through crediting rounds with the project-specific calibration that we build. So that's really good because it means that we have really great performance of the model that's specifically developed to your property. In crediting rounds, it's 90% of those samples that are then measured with spectroscopy. And it's really exciting. The technology is not new. It's been around for about 50 years. And in Australia, between I think the University of Sydney, CSIRO, and some work in WA, we're really global leaders in the development of this technology too. And I think the reason why I'm here today is a confluence of all those moving pieces. The other benefit that we have there in doing our baselining and our crediting rounds through the ERF credit method with spectroscopy is we can also then use that to put the data onto the Home Lab Red handheld instrument. What that means is that we can start to test data in field rather than from a centralized lab. I should put the caveat there that any formal sampling rounds do still have to go through a lab in order to conform with audit practices, but certainly in between rounds or across your property to monitor carbon stocks, we see this as a really valuable tool. We moved from, with that handheld deployment, a cost per sample, and each time you're pulling a core, thinking, you know, out for 70 to 150 bucks to measure my carbon, to unrestricted testing. Of course, it's scalable and we can deliver results in almost real time. It's probably about 3.5 minutes to collect a measurement with the Home Lab Red. I can speak a little bit more if there's questions about how we do that on the soil. And finally, just be mindful of time. I think, how can you get involved on the line as we roll out this technology? So Home was awarded, as Sean mentioned, $3.3 million under the National Soil Carbon Innovation Challenge to demonstrate the use of the Home Lab Red and its capacity to reduce the cost of soil carbon measurement. What that means is that we are taking these instruments that we know perform very well under a laboratory environment, sending those out to landholders who register project partners. And with that, you get financial incentives to support the start of your carbon project, which help to support soil coring, testing, set project mapping, but also cost-free access to unlimited soil testing with the Home Lab Red for 12 months. And what we'll be seeking to do there is to really quantify how does our in-lab performance translate into field environments, and how does that deliver value, not just at the point measurements, not just at formal sampling rounds, but between sampling rounds, to understand how carbon levels are changing across your property through time. And I think we'd encourage anyone here who's interested in getting their hands on a Home Lab Red, and also exploring what that means for your carbon project, please speak to Sean at Atlas Carbon and get involved. And that's about all. I've got my email there, and happy to take any emails or calls outside of this presentation.
Excellent. Thanks very much, Simon. Yeah, as I said, feel free to put any questions you have for Simon into the chat. I'll kick off with a few. So what's the grand plan here, Simon? Like, in the end, can we look forward to being able to do in-field measurement with a handheld device, you know, putting aside regulations and whatever else, that the future will be basically doing it this way rather than sending it off to labs?
Yeah, absolutely. We see it as application not only within carbon, but I think other variables of interest. I haven't come up with a more appropriate metaphor here, so I guess I'm just going to put it out there. You know, I kind of think of carbon as a gateway drug to soil testing with handheld testing, and that ultimately what we're going to be doing is, and we know that the capability of the technology is there, is that we test things like pH, like cation exchange capacity, like texture, and those other drivers of soil health. And we see, I think, this handheld testing, putting the power back in the hands of the growers rather than a dependency on independent contractors, soil sampling labs, or feed or grain testing labs for that matter.
Yeah, we've got some questions coming in. How long does it take to do a hectare? Is Hone ERF certified?
Thanks for the question, Jack. Really appreciate it. Hone is certified, so the ERF doesn't actually provide certification. Your come to Jesus moment really happens at the audit stage. For the carbon measurement itself, we use NADA and ASPAC accredited partner labs to ensure that we're getting the highest quality measurements there. And we have independent audits that are moving through our facility currently, actually, to validate that all of our measurement processes align with the minimum ERF requirements. And we do have a regular line to the ERF and shooting questions to them at any time that we need to. With respect to how long does it take to do a hectare, I guess how long is a piece of string? That really will depend on what your sampling density and what your sampling program looks like. On a per sample basis with the Home Lab Red, as I said, we're looking at about 3.5 minutes. How you would prepare that is you can go out and collect cores. You can also chuck a shovel in the ground and turn a shovel over. We've really designed it to try and fit around the tools that you have and the workflows available to you.
Thanks, Simon. Colin is interested about the accuracy of the portable device compared to lab assessments?
Thanks, Colin. So with respect to lab measurements, and I think if you go to the Australian Soil and Plant Analysis Council website, ASPAC, you can see their ring and proficiency testing for all of the analytical labs and for all of their methods year on year. It's a really good and solid database to see. I think there's always a little bit of a question of, I send to this lab or I send to that lab and I get a different result. What does that look like? A fantastic resource. So the combustion method itself is really quite accurate on the sample that goes in, but it also has a disadvantage that you're sampling 200 to 300 milligrams of what can be a multiple kilogram sample that's going through the lab. So that's not that sampling error is not captured in the ASPAC reports. What we see on the instrument is that we get on our best models, we have an error of about 0.17%. We find that comparable to technical replicates that we pass through the lab, which are generally at 0.05 to 0.1%.
Excellent. One from Sophie. Do the soil samples in this field need to be ground before they can be scanned, or can an impact core be scanned?
No, and that's one of the fantastic benefits with NIR is that it's designed and it works where NIR is near infrared spectroscopy. It's designed and works under field conditions. So you may have heard of mid infrared measurements, which are actually used by some labs for I know on the West Coast and in South Australia for their in-house carbon measurement. But that does have the requirement to dry and sample. So short answer is no. No grinding required. Intact core can be scanned. The really important thing with home lab red is that you have good contact between the instrument and the substrate or the sample that you're trying to measure.
And one from Clinton about if the home lab red can be used with the 2021 measure model method.
Yes. So to put a bit of context around that, we have Schedule 1, which is the direct measurement method under the Emissions Reductions Fund, and Schedule 2, which is what is called the model measure model approach. So that model measure model approach is effectively you develop a model of carbon stocks across your property using satellite and other available covariate data that you have. You then go back later in time, perform direct measurements. So you pull some soil cores and get some data on that. And use that to determine how well your initial model has performed. You can then take that data, retrain the model, and I guess iterate through that cycle. It gets a little bit messy when we speak of models because we speak here at home of spectroscopic models, and I think generally in the ecosystem we speak of property level or satellite-based models. Spectroscopy can be used for the measure component, that model measure model approach. But it's not something that we here at home have yet directly engaged in as we really focus on that direct measurement pathway. I'll just take it and drive here, Sean. So I see Jane's question come through, the name of that resource. It's the Australian Soil and Plant Analysis Council. But I'm sure that we could distribute something after the fact with some links and things that have been spoken to.
Yeah, just a heads up on that. So for all registrants, we'll send out a recording of this presentation. So anything you missed or want to follow up on, this will be available. Dan, what are the approximate costs for producers to use home, hire or buy?
Yes, so the instrument itself retailed at $8,000, but under the National Soil Carbon Innovation Challenge grant, we've actually got this really nice structure set up where the instrument gets deployed effectively under a 12-month lease agreement. So that's at no cost to the landholder with access to unlimited testing. And then at the end of that 12-month period, you have the option to purchase. And I think, for us, our objective there is to deliver something in that period that you'll say, well, hang on, I want to hang on to this and keep it in the glove box of the ute because this is something that adds value. So we're not selling the soil instruments into the market at the moment. We do have a separate device for measuring grain quality, specifically moisture and barley and wheat moisture and protein. It has a total retail cost of $7,000 that's available and in the market for this harvest. But on soil testing, we're slow rolling that a little bit. And really the access to the instrument is through the National Soil Carbon Innovation Challenge and Atlas Carbon.
Alrighty, I'll throw in one here. Obviously, there's the work that Hone's doing, the sort of other work in Australia, but this is a global challenge, and there's a lot of effort and interest in many other countries. Is there any sort of particular work that you're aware of, Simon, that is going to be important for the future?
Yeah, I think it's as you rightly say, Sean, it's a huge challenge globally. I think we moved from the agricultural revolution and then the impetus on chemical inputs to drive outputs that really started earlier in the 90s. It ramped up, especially in the US in the 90s. And I think now where we're moving in agriculture is the real gains that we'll start to see is on a precision basis, and key to more precise, whether it's application of inputs or understanding of outputs, is greater measurement. I don't think that's a surprise. I don't think that's a secret. I think that's where a lot of people are working. So we see a lot of work internationally on the satellite-based modeling space. It's a low barrier to entry, and there's a whole lot of data that's readily available. We do see other players in spectroscopy in Europe and North America, but what we typically see are those are probe or drill mounted tools, which given the disparate bulk densities, I think between Australia and America, those tools generally kind of fall over. And then, we also see some consolidation in the analytical labs, particularly in the US market, to focus on carbon and environmentally based testing. But we don't see dramatic changes in those gold standard traditional methods coming through at a rapid clip.
Okay. I've got one more in the chat from Drew. Does the soil need to be dry to measure it?
No. Good day, Drew. How are you? No, the soil does not need to be dry to measure it. And so, I think that's the three biggest things that affect the capacity of NIR to measure effectively are temperature, humidity, and particle size. And that's really, I think, a big part of the secret sauce for us here at home. One piece is the capacity to build these hyper-localized project-specific models and deploy those to a mobile application or a desktop application where you can readily access the capacity to measure and the data. The other part of our secret sauce is really compensating for those environmental conditions. So we prepare our instruments over a range of 5 to 40 degrees with respect to temperature, moisture and humidity, and we work up to, it's about 25% soil moisture. At that point, you start to get a bit too much interference in the NIR signal to be able to accurately measure. And particle size, we also have some intellectual property around correcting for the scatter effects that occur as a consequence of that.
Thanks, Simon. We better wrap it up there because we're coming close to time. Like I said, this recording of the session will be shared to everyone who registered. For people who are interested in taking a look at a soil carbon project, just to explore the opportunity, Atlas Carbon offers a free cost benefit report. So that'll look at your property. We'll get some basic data off you, and then we'll see what it would cost, looking at obviously soil sampling, but also water and wire, soil and pasture, as well as the potential uplift both from carbon credits and for your property's grazing productivity. So yeah, as I said, that's a free one. It's high level, but it gives you an idea of if your property is suited to running a soil carbon project on. At the end of the session, there'll be a link that comes up, which you can click on to put in an expression of interest. And yeah, if you are interested about the Hone grant through the National Soil Carbon Challenge, and working with both Hone and Atlas on having a Hone Red in your hands, as well as getting some financial support for your carbon project, yeah, please get in touch and we can talk to you about that as well. So thank you very much, Simon. giving us that insight, and thanks everyone for joining.